So hi students, welcome to the channel. Today in this class, I'll give some suggestions for all the students of class 10 who are going to appear for the pre-board examination. So today's topic is trigonometry, and I'll pick few important problems and I'll explain them. So uh, be with me till the end. So the first question is 1 plus sine theta whole square plus 1 minus sine theta whole square by 1 by 2 cos square theta, which is equal to this, and we need to prove this. Okay, this is a proof. So let us do. So we'll take the left hand part of the proof, that is 1 plus sine theta whole square plus 1 minus sine theta whole square all divided by 2 cos square theta. So the first step, if you know few formulas from class 9, that is from the chapter expansion, then it will be a very quick process. So if you can write this a plus b whole square plus a minus b whole square, we have a direct formula, that is 2 times a square plus b square, and this we write here. You see, this is a plus b and this is a minus b whole square, and in between there is plus. So exactly it looks like this. So I'll write, since this we have, so I can write 2 times 1 square, then plus sine square, and downside we have 2 cos square theta. Okay, so then we can see that this 2 and this 2 can be cancelled, so we have 1 plus sine square theta by cos square theta. So now we can take separate divides for both the numerators. So this is 1 by cos square and this is sine square by cos square. So 1 by cos square can be written as sec square theta, because reciprocal of cos is actually sec. We know this, we have formulas. Okay, and then sine by cos is actually tan, so sec square plus tan square. So it's simply means we have proved this, that is sec square plus tan square. Okay, so next I'll move to another sum. So that is 1 plus tan square theta by 1 plus sec theta is equal to sec theta. So again this is a proof. So it is again a simple sum, but you need to understand all the formulas thoroughly. So as I'm seeing here that this is tan square, okay, so we have this formula, that is sec square minus tan square equal to 1. We know this, okay, we know this, and from here I will try to find tan. So sec square, and I'll bring 1 to the left hand side, and I'll take this to the other side. So now I have tan square, which is 1 minus sec square. So it's better to write in the place of tan square sec square minus 1 divided by 1 plus sec theta. Okay, so this is our LHS part. And then again, if you have some idea about the algebraic formulas, that is a square minus b square, that is a plus b and a minus b. So this formula will apply in the numerator part again. So 1 plus 1 can be written as 1 square. There is no issue in writing 1 as 1 square. So now this is sec square minus 1 square. So that is a square minus b square. So we write sec theta plus 1, and again we can write sec theta minus 1, and the division part is this denominator part. So we can cancel these two. So again we have this sec theta minus 1. So again you see that we can cancel these plus 1 and minus 1. So therefore we have sec theta. And again we arrive to the proof what it was asked. That is sec theta. So it's very simple if you know certain formulas. Okay. Okay. So let's move to the third sum. So third sum is sine theta, sorry, sine A by 1 plus cot A minus cos A by 1 plus tan A. Okay. This is equal to sine A minus cos A. So we'll take LHS. So most of the time we see that the proof comes from LHS part only, and sometimes like we need to take both. Okay, so it depends on the question. We need to uh, analyze the question, that whether we need to do only left hand or we need to take both the parts. Okay, yes. So the next problem is this, and how to start. So as you can see, the right hand part, that is only sine and cos, but here it is cot and also the tan. So we need to change these two, cot and tan, into sine and cos. Then we'll see what we can do next. So I'll write sine A by 1 plus cos A by sine A, and then minus cos A by 1 plus tan A by, I'm sorry, this is sine A by cos A. As we have discussed just now, that we need to convert everything in sine cos. Okay. So next is we can take LCM in the denominator. That is sine as LCM here. Okay. So the numerator will be sine A, because this will cross here, and then this is cos A. Okay. So again you can take LCM to the second part of the question. That is you get cos here, and the LCM again is cos A plus sin A. It's the same. Next what you will do is invert this sign and send it to the numerator. So it becomes sine square then, and then downside you have sin A plus cos A. Okay, I'm sending this to up. Why I'm saying like this? Because if we have 2 by 1 by 3, what we do is 2 into 3 by 1. This is what it's going to the numerator only. As we do reciprocal for this fraction, and then we multiply. So the same thing I did here. Okay. So cos A, and again this cos also goes to up. Then we have cos square. This is again sin A plus cos A. Okay. Next we can take LCM. You see the LCM is same now. So that is sin A plus cos A. And the numerators remain same. That is sin square A minus cos square A. So again we can take this formula, that was A square minus B square, which is A plus B and A minus B. So then I can write sin A plus cos A and sin A minus cos A, that is A plus B and A minus B, and downside it's sin A plus cos A. So you can cancel these two, and finally you have sin A minus cos A. I hope you are enjoying the video. So quickly we'll go to some more problems. That is question number 4. We have 1 minus tan theta by 1 plus 1 minus cot theta whole square, and we need to prove it as tan square theta. So we take left hand side and we see that there is cot there. We'll change it to tan. So 1 plus tan theta, and in the denominator we can write 1 by tan theta, because we know that cot is reciprocal of tan and tan is reciprocal of cot, and I've already separated the powers as well. And then I can take the LCM in the denominator part. So then we have tan theta minus 1, and also the denominator is tan theta. So entire square is there. So next is 1 minus tan theta whole square divided by so one thing I would like to do here is the numerator contains 1 minus tan and denominator is tan minus 1. So there is no issue in writing a minus b whole square is equal to b minus a whole square. Okay, make sure you understand this, because whenever we do a minus b whole square, the negative part is only minus 2ab, and rest a square and b square are already positive. Okay, same thing we get here also. B square and a square is already positive, so the negative part is 2ba, and in fact they are same. So that's the reason why we can write a minus b whole square as b minus a whole square. So I'll write as 1 minus tan theta whole square, and denominator we have tan square theta. I'm separating the power now. So then you see we can cancel these two parts, and then we get 1 by 1 by tan square, and then it can be converted to its tan square by this property just we have discussed in one problem. So it will go up. Okay, it will go up. The same manner we did this. So again we reach to a proof. So we'll pick up few more sums. Okay, so hope you are concentrating. This is one of the important one. Sine theta minus 2 sine cube theta by 2 cos square theta minus cos theta equal to tan theta. So again we choose left hand part to bring the right hand. So you can see that in the numerator we can take sine as common. So then in the bracket we are left with 2, 1 minus 2 sine square theta. And same for the denominator. If you take cos as common, because you can see cos is there in both the terms. So then we have 2 cos square, 2 cos theta. I think there is a mistake. Yes, this is cube. So there will be square minus 1. So next is sine theta and 1 minus 2 sine square theta. Then in the denominator we'll change this cos to sine. So we can write 1 minus sine square theta instead of cos square. So then we have this sine theta, and then 1 minus 2 sine square theta, and denominator is cos theta. That is, if you multiply this, 2 minus 2 2 sine theta minus 1. And so which gives you which gives you sine theta, and 1 minus 2 sine square theta, and it is cos theta, and this is see 2 minus 1, we get 1, and minus sine square theta. So we can cancel these brackets, and then we have sine by cos that we can write tan. So it's again a simple one, but see, if you remember all the formulas, then it's quite simple to solve the proofs of trigonometry. Okay, so before starting these proofs, at least you should have a quick revision of your formulas. Okay, so without going into formulas, if you're trying, then you may stuck somewhere. So it's better to go through formulas once and then start this proofs. Okay, so I'll do one last problem. Okay, then we'll come with some new chapter. 1 minus cos A by 1 plus cos A is equal to sin A by 1 minus cos 1 plus cos A. So how to do this? So as we are seeing that there is a root, so we have gone through these rationalization case in class 9, so we'll do that because we need to remove the root which is not there in the right hand side. So we take the left hand side. Okay, we need to prove this. So that is left hand side LHS. We see that it is 1 minus cos A by 1 plus cos A. So if you notice that the denominator is not disturbed, it is the same. So we need to change the numerator only. Okay, so I'll change the numerator by multiplying this. Okay, so we have 1 plus cos A in the denominator. So 1 plus cos. So I've chosen this factor as the rationalizing factor because I want to change the numerator, and as because the sign is minus in between, so I've taken plus and multiplied. Okay, so you have a square minus b square in the upside. You see 1 plus cos and 1 minus cos, that is a square minus b square, and denominator you will have the same thing, but you can write as square. Okay, whole square. So then upside you see 1 minus cos square we are getting, and denominator is 1 plus cos A whole square. So 1 minus cos square, what we can do is we can write as sine square, and then 1 plus cos A whole square. So finally you can remove the square from the numerator and square from the square root from the numerator and denominator, as because we have uh, arrived to the squares inside like this. If we have a square by b square, so these two squares will help to remove this root and we get a by b. Okay, they cancel out usually. So we write sin a by 1 plus cos a. So hope you learned, and I have done a very few sums, but you should try, and if you get some doubts please comment. I'll come with another video. Okay, so thank you for watching. uh, have a good day.